example 2, do in-store location and permissibility of mobile payment impact sales at the 5% significance level? So in business, what we're interested in most of the time is that we want to maximize our profit or we want to increase our sales. So in this example, we're looking at ways to increase our sales. We're looking at if these factors will impact our sales because we want to look at ways to increase our revenue. And when we're looking at the data set here, how we know this is two-way ANOVA is because we have two factors. First factor is your locations. We have the in-store location for the mobile payments, right? So we have the in-aisles, front, kiosk, and expert. So that's the in-store location. And then in the row, we have the permissibility of mobile payments. So we have yes for mobile payment, we have no for mobile payment. So we have two factors here. And when we look at the data set, these are numbers, these are numerical variables, these are the sales, these are numerical variables. So that's why we know that this is two-way ANOVA. We have two factors and these are numerical variables. And in this question, what we're dealing with is we're trying to see if these locations, these four locations, or the mobile payments options will help us drive sales. That's what we're looking at. So I'll show you how to run the ANOVA analysis in Excel right now. So in this example, our first step is to enable the data analysis. So again, File, Options, Add in, Go, and then we're going to check off the Analysis Tool Pack. So File, Options, Add-ins, and then Go, and then we're going to check off the Analysis Tool Pack, and then we'll press OK. Once that is checked off, then we're going to go to the Data tab, and then we're going to click on Data Analysis. So Data tab, and then Data Analysis. And since we know this is two-way ANOVA, so what we're going to choose is we're going to choose ANOVA two-factor with replication. So we're going to choose the second one, ANOVA two factors with replications. And then for the input cell, what we're going to highlight is we're going to highlight B5 all the way to F15. So B5 all the way to F15. And we're including the headings. We're including the B5. So we're including the row 5. And then next variable that we need to input is the row per sample. And row per sample, we're going to put 5 there. So the reason we're putting the 5 is because we have 5 row for no, we have 5 no, and then we have 5 row for yes. That's why we put the 5. We have 5 row for no, 5 row for yes. So therefore, there's 5 per sample. And then our alpha is 5%. We're looking at 5% significance level. Once we have inputted these three things, we press OK. And then Excel will generate the ANOVA table. And what we're interested in is the bottom here. This is the ANOVA table that we're interested in. A couple of things that you need to note here. The first thing is that F is your F statistics. So F is your F statistics. F critical, they give it to you already. So you can compare F statistics and F critical. It will give you the conclusions. So that's the first concept that you need to know. Second concept that you need to know is that you need to know the relationship between sum of square, degree of freedom, and mean square, and F statistics, right? So mean square equals to your sum of square divided by your degree of freedom. So that's why we have the 24 divided by 3, that will give you the 8. So sum of square divided by degree of freedom give you the mean square. And you also need to know how F statistics is calculated is you take the mean square and then you divide it by the mean square for the error term, which is your mean square for the within. Third things that you need to know is that your probability, your p-value. P-value sometimes they're given to you as scientific notations, and you need to know how to convert them into the regular number. So right-click, Format Cells, and then you're going to click on Number, and then you'll see that we're going to increase the number of decimals until we can see a number that we can understand. So we're going to increase the number of decimals. Once we see a number that we understand, we press OK, and that's what that number represents. So you need to know how to convert the number from scientific notations to a regular number, so that way you can understand what they're talking about. That's the third concept. Fourth concept is, again, you need to know how to calculate the p-value and critical value. P-value is f.dis.rt, and critical value is f.inv.rt. So we're going to go through these 4 concepts right now. So the first concept is that we're given the F statistics and we're given the F critical. And with these 2 numbers, then we can state our conclusions. So we have the F statistics and the F critical for the sample, for the column, and for the interactions. So sample is your row. So in the row, we have no and yes. So we have yes and no for the sample. So that's why our degree of freedom is 2 minus 1. So we have 2 different samples. We have yes or no. So 2, that's why we get the 2. So 2 minus 1 will give you the degree of freedom 1. Same idea for the column. Column is our location. We have 4 locations. We have in-aisles, front, kiosk, and expert. So that's why we have 4 for location, -1 gives you the 3 for the degree of freedom. So sample is your row, column is your column. So once we understand what the sample means, what the column means, then we can compare the statistics and the critical, and then we can make a conclusion. We know that statistics is greater than critical for both the sample and the column. So we have 62 is greater than 4, we have 98 is greater than 2.9. So for both of them, your statistics is greater than critical, so therefore what we're going to do is we're going to reject H0, and then we're going to accept H1. And what we're accepting is that for sample, what we're accepting is that the permissibility of your mobile payments will impact sales. Same for the column. We're going to reject H0, we're going to accept H1, and what we're concluding is that the location is your column, so location will impact sales. So that's what the F statistics and F critical tells you for the sample and the column. And for the interaction is looking at the relationship between your sample and your column, your A and B. And when we're comparing the F statistics and the F critical, what we can see that is that statistics is less than critical, so therefore we do not reject H0. And what we're concluding is that there's no relationship or no interaction between the location and the permissibility of payments. Next, you need to know how to calculate the p-value and the F critical. So p-value is f.this.rt. So for example, to calculate the 0.7469, how we calculate the p-value here is we use f.this.rt. Asks you for 3 variables. First variable is your F statistics. F statistics is your 0.4099, so that's what we put here. That's the first variable. Second variable is your degree of freedom 1. Third variable is degree of freedom 2. So degree of freedom 1, because we're dealing with interaction. So for interaction, we use the degree of freedom. We use the degree of freedom, which is 3. And that's your degree of freedom 1. Degree of freedom 2 is your 32. That's for your within. This is for your error term. And that's your degree of freedom for the error term. And that's your degree of freedom 2. Same for f.inv.rt. First variable is your alpha. Alpha is 5%. Second variable is your degree of freedom 1. Degree of freedom 1 for interaction is basically the degree of freedom for itself, which is 3. Degree of freedom 2 is always for the error term, which is the within, which is the 32. Once you plug that in, you're going to get 2.9011. And that's example 2.